Swayam Prabha. Digital India. Educated India.
When we are talking about AI again, nowadays the big craze is all about generative AI, Gen AI, ChatGPT, Llama, and all that. But the way I wanted to start this was that how the software revolution has been in the last 40, 50 years at least. It's also impacted the industry. Okay. So, of course, these terms are something that got coined only in the last few years, but you might have come across these terms called Industry 1.0, Industry 2.0, etc. And we are now currently in Industry 5.0, as we call it. And till a few years ago, it was Industry 4.0. What we are trying to show out here is how this period has actually, the industrial revolutions that have been happening, okay, how they have been impacted by the development of AI. Okay, so when we are talking about the pre-1970s, most of the AI revolution was all about basic I'm also trying to depict how the definition of AI itself has changed over the years. Okay, so concepts of word embeddings and bag of words were just coming into the the scenario in the 40s and 50s, and therefore industry so far was not impacted so much even by software, for that matter. To talk about AI impact, okay, but Industry 3.0 onwards, what we started seeing was a lot of these automations started coming in, and in these automations, we have a lot of impact that started coming with respect to software, and also within software from various AI related developments which are happening. Okay, so when we are taking a look at Industry 3.0, there was a lot of mechanical automation which came in. Okay, and at the same time, this was also aided by a lot of rudimentary AI related automations also, concepts like TF-IDF, deep learning, all these things started coming in, and we started getting all these benefits. We were talking about automation, and a lot of the the improvements in machine learning, etc., also started coming in during this time, and deep learning, etc., came in, which really changed the ML scenario itself. And that is where we see consequently an impact on the industry also, where digitalization started picking up pace. Okay. Now, of course, when we are talking about Industry 5.0, where there's a lot of personalization, that's where things like NLP, NLU, etc., NER, all these concepts started coming in. And of course, in the last 3-4 years, we have these concepts of the transformers, which have actually transformed the ML scenario and brought in LLM. So I just wanted to go through this kind of a historical perspective before we deep dive into AI and ML. Okay, so having talked about now, let's take a look at the various facets of AI. So when we are talking about AI, we have the very basic machine learning, where you have the typical training a machine to start learning the way humans learn, and more of artificial neural intelligence, etc. We are currently, what we say is, we are in the middle of stage 2, where we have not yet hit AGI. AGI is nothing general intelligence, but at the same time, we have made pretty good advances in the concept of machine intelligence. Okay, and the ultimate machine learning utopia or grand plan would be when we can actually achieve artificial super intelligence. Okay, where the machine consciousness comes into the picture, and machine capability goes beyond human capabilities as well. Okay, so you might have, of course, come across all these Chat GPT and Llama and all, they are able to now pass most of our engineering entrance exams and lawyer exams and finance and economics related exams, etc. So that's where we are right now, and we are taking a look at maybe reaching ASI a few years, if not a few decades, or sooner as well. So that's where we are in the overall scheme of things. And if we take a look at how this field of AI evolved, so first, when we talked about data and computerization, it was all about putting the data into a digital format. Okay, so you started having data. Then you started having data warehouses and data analytics. Okay, where you can actually slice and dice and generate reports. To tell you some, that typical data pyramid also. So you have raw data, then you have massage data, then you have information, and then you have knowledge, and then on top of that you have insights. So that is something that you could achieve with data analytics. And then within data analytics, when you're talking about something like an enterprise data analysis or EDA and all these concepts, that's where AI came into the picture. Within AI, you have this subset of machine learning where you can actually train machines to learn the way humans have been learning. And then how to speed up that learning and how to make it much more powerful. That's where the concept of deep learning came in. And finally, now a subset of deep learning is where you have generative intelligence, where after you have done all the learning, you can actually generate content and output, which is very tough to discern whether it's something generated by humans or generated by the machine. Okay, so that's the current scenario around deep learning. Okay. Now taking a look at the various types of machine learnings, again, we don't, each of these subjects, please bear in mind, each of these subjects is something that you can spend, so just, I'm in the last week of doing a 3 months course on machine learning from IIT Kharagpur. Okay. So you can very well imagine, so something like a machine learning topic, we cannot try and cover within say in half an hour. So I'll not go into too much detail. But at the same time, what I want all of you to achieve from this session is, for those of you who are experts in AI and ML, all this will be very basic information. But my idea behind this session is to try and have everyone in this audience, when they go out of this meeting, all of you should have a general idea at least about the various terms that are being spoken about these days in the industry. Okay, so that's why I'm trying to the entire field of machine learning, traditional ML as we call it, I put it in one single slide, and I'll try and cover it in the next 5 minutes or so. So please bear with me. Okay. So when we are talking about machine learning, so there are these various options which are available to you. So the first option is supervised machine learning. So this in the best example I can give is what all of us go through in our school days, right? So when we started our schooling in pre-primary or primary, etc., we had supervisors or teachers who were telling us that, okay, this is an apple, this is an orange, and these are another picture of an orange, this is another picture of an apple, etc. And that is how our brain started learning that, okay, if I'm told that this is something, I can actually try and recognize, so that next time I get 2 more images, I can try and, so if I don't know if all of us remember our junior KG days, but I'm pretty sure this is how we were taught, right? So we were taught that, okay, this is an apple, and then we were probably shown another photo, and we were asked that, okay, can you tell what is, where is an apple in this collage of photos, where is an orange, can you identify, right? So that is exactly what we are trying to do with machines when we do supervised learning. So basically what we do is we label certain data. Okay, so that is why it's called a labeled data set. And that labeled data set, you have certain mathematical algorithms or statistical algorithms. Once you provide this labeled data to these algorithms, they are able to learn that, okay, what are the features? So, when you train these algorithms, they are actually able to go into the deeper aspects of these. So for example, if we are talking about, say, pictorial data, okay, like this, so apple and orange, the algorithms are able to actually make out that, okay, this is an apple and this is an apple. Let me try and identify what are the common things between this and the other photos belong to an orange. So I'll try and identify what is common between the oranges. And I'll also try and learn what are the differences between an apple and orange. Okay. So all I have to do is, instead of having to, define, okay, an apple is typically red in color. It has, green leaf around it or something like that. And an orange is orange in color and it has more, spotty texture on the skin, etc. So instead of me having to tell the machine what actually is an orange and what is an apple, I'm letting the machine itself try to figure out. Okay. And how does it figure out? By giving this labeled data. Okay. So that is why it is called learning, where you are providing labeled data to the machine and the algorithms are able to make out, okay, what are the features. So you'll typically hear these terms being talked about: feature engineering and feature identification, etc. Okay, so the machine is trying to learn what are the features, what is common between these two apples, what is common between these three oranges, and what is the difference between an apple and an orange. Okay, so that the is given new data, test data, it is able to correctly predict that, okay, this is an apple, this is an orange. Okay, so that is your typical supervised machine learning. In industry, it is wherever you have these labeled data sets which are easy to provide, and your business problem is more around prediction. Okay, so if you want to predict what's going to happen. So if I take a industry use case, customer churn. Okay, so customer churn is a typical prediction use case where, say, if I'm a Vodafone or I'm an Airtel, I want to predict if if one of my customers who's taken a SIM card from me, suppose I am a Vodafone, and I want to make sure that he stays with me, right? So that he keeps every month or, prepaid, postpaid, whatever is the user, he keeps giving his money to me. Is there a chance that he will, switch from my Vodafone services to, say, an Airtel? I would like to predict that. So that is where we will try and provide data to the algorithms of customers who are continuing with Vodafone and customers who have left Vodafone. And we'll all give all sorts of data to it. So we'll give it, their billing data, their usage data, how much data did they use, how much talking minutes did they use, etc. How many tickets did they open? Were they unhappy with any of the services? What kind of feedback were we getting from social media, etc. So the entire data we'll give, and we'll tell the algorithm that, okay, these are the customers who are continuing with us, and these are the customers who have left us. Now understand the features, and now I'll give you a fresh customer data and tell me how likely is he to leave me and go to an Airtel. Okay, so that is a customer churn prediction, a typical use case for supervised machine learning. Okay, so that's your supervised ML. When we are talking about unsupervised learning, it's basically where we don't have any labeled data. And one more thing to mention is these prediction algorithms and everything. While you and me as humans, we have, at least so far, we have better intelligence than the machines. So maybe given 10, 20 photographs, we can start making predictions. Okay, but a machine typically requires labeled data in at least tens of thousands, if not millions of records. Okay, so that is where this, and we'll take a look at why ChatGPT and all have become extremely famous. So typical supervised machine learning problems used to take months because you had to label hundreds of thousands of data and then train the the algorithms to be able to predict better. But what if you have a scenario where you don't have this labeled data? So and you have a huge amount of data. So what do you data? You do unsupervised learning, where you tell the algorithm, you give the entire data set, and you tell the algorithms you only try and decide and categorize. Okay, so instead of prediction, this is typically a categorization or classification kind of a problem, where you give a bunch of data to the algorithms and they will come up with various categories. Okay, so this is if I take an industrial use case, I'm currently doing this for one of our clients. That is your document classification. Okay, so when they have so currently we had this use case where one of our clients, they had these they were into the sustainability that department of that client, and they had lots and lots of material which had been built over the years, and they wanted to categorize that data. Okay, which of this material is actually related to decarbonization versus which data is about alternative fuels, etc., like that. And we gave it to an unsupervised learning algorithm, and it was able to then categorize it into different categories. Okay, so that's your typical example of unsupervised learning. And then you have semi-supervised learning, where sometimes you first use unsupervised learning to get these categories. Then you are able to make out that, okay, this seems to be brinjals, this seems to be onions, this seems to be capsicum. So now I will just blank, go ahead and label all this data as capsicum, all this data as brinjals, all this as onions. And now I can actually feed it to a supervised machine learning algorithm and start making predictions. Okay, so that is kind of like a example of a semi-supervised learning use case. And then reinforcement learning is another type of learning where essentially you are giving a goal to the machine and you're telling it, in one way we say reward versus punishment. Okay, so every time the machine takes a decision, we have certain conditions where it can make out that, okay, this is the decision that I took deserves a reward, or does it deserve a punishment. Basically, the machine is able to make out whether it is reaching its target or not. Okay, so every time, so you have an environment, the machine takes an action, and then based on the action and the observation, the machine can make out whether it has supposed to get a reward, or is it supposed to get a punishment. So this is a typical example of a maze, solving a maze problem, right? So this is typically an industrial use case, if I may put, your autonomous vehicles. Okay, so you have the so when you are hiring this Tesla cab, all you have to do in the Tesla cab is you have to tell it that, okay, I have to reach XYZ destination, and then the entire the navigation and which route to take, which route has more traffic, which has less traffic, which route is closed, etc. That entire decision making, and then the actual driving on the road. So all of that, making sure you're not hitting another vehicle, making sure that you are following all the traffic rules, the signals, the speed limits, etc. So all that is the environment, and then you have given it a target, and these reinforcement learning algorithms are able to take actions so that they reach the target. Okay, so that was like a quick 5-minute introduction to traditional machine learning. Okay, now I'll quickly skip to a data point where we are saying that as of last year, we were seeing that of AI projects, about 90% of projects were traditional ML, and only 5-10% were generative AI, and still a lot of these projects are still in POC mode. Though we, in the last 3-4 months, we have started seeing a lot of our POCs actually go into production. Okay, but in the next 5 years or so, what we are expecting that the picture will change entirely. We'll have almost percent of projects around generative AI, and only 10% of them traditional, and we'll start seeing some projects coming in on the AGI, the artificial general intelligence that I was talking about. So what I'm trying to explain here now is, why is it that we are seeing this shift, okay, or we are predicting this shift. So if I take this, the typical AIML life cycle, usually it starts with the business requirements, and then a big amount of effort actually gets spent in this portion, where you collect the data, you have to explore the data, you have to prepare the data, and then you have to do the model selection and model evaluation. Okay, a lot of times is spent in this. So if I take the case of one of my projects, we delivered 5 use cases of traditional ML to our client. There was a team of about 10-12 of us, and we literally slogged for a year and a half. Okay, for those 5 use cases. And when I say slogged, almost every month, maybe 2-3 weekends, was spent working, and every normal working day also stretched well beyond 9 hours. Okay. So with a team of 10, it took us 18 months to deliver 5 use cases. And so if I take three, 5 use cases in 18 months, around 4 months, per use case. And out of those 4 months, almost 2 months or so was spent in this data collection to model evaluation. Okay, phase. So because as I was talking about, so you have millions of records which you need to train, if not millions, at least 100,000, if not 100,000, at least 10,000, etc. Okay, so the data labeling, collection, everything is something that actually takes care, takes bulk of your time. So why is it that generative AI suddenly, and then of course, why is generative AI actually, or ChatGPT or all these, why have they created such a buzz? Because in the case of generative AI, that entire data analysis, preparation, model selection, evaluation, etc., is taken care of you, because you have something like a ChatGPT or a Llama model available to you on day one. Okay, so you don't have to do any of that activity. Okay, all you have to do is you have your data, you have the the ChatGPT, Llama, Gemini, all these. So Google solution is Gemini. So you have the Gemini LLM available for you, and you just send your data to the LLM. You ask it a certain question, and you will get the answer for it. So this entire, and then we are into n, which is the number of use cases. So I was talking about 5 use cases. So each of those use cases, we had to actually repeat this entire cycle, uh, go through it, label the data for each use case separately, do the model training, model evaluation for each of these use cases separately, etc. And now my same LLM, so the use cases that we were talking about were, language related use cases. So we had to classify an email, we had to classify documents, and then we had to extract certain data from the email body, and we had to extract certain data from the documents. Okay, there were 2 different types of documents. So that was the total 5 use cases which you had, and it was all language related. Okay, so now with a language LLM, large language model like say a ChatGPT or a Gemini, all you have to do is I can send that email body to say Gemini, and I can ask it, okay, tell me what email is this? Is it an email which is, is it a customer grievance, or is it a customer asking for opening some new service with me, etc., or taking some new product from me, etc. So is it a sales email or is it a service email? Okay, so an LLM can easily understand the language and tell us that classification. Okay, similarly, if I provide the text of a document and I ask it what kind of document is it, the LLM can immediately tell me within seconds what document is it. Is it a decarbonization document, or is it say alternate fuels document, etc. So like that, it can immediately understand because of the power of these LLMs. Okay, so that's the so that's the whole magic of large language models which have come up, because they have been trained on huge amount of data set, and now all you have to do is just adapt it for your particular use case. Okay, so that's your typical LLM. Why they have got the fancy of everybody. And just to show certain size related, so when we say large language models, right? So we started with BERT, etc., which were dealing with thousands of data points, and now we have all these models which are like 200 billion, 300 billion parameters on which it has been trained, and it is ready to act on. Okay, so that's how. In fact, they have now become so large that in the last few months there is also a lot of development which is happening on small language models. Okay, because obviously large language models require that large compute, storage, etc. So now for very specific use cases, if you want to use these large language models, you have this concept of small language models also, which are available. One more thing which I forgot to highlight in this particular slide was that, so earlier, as I was saying, for 5 different use cases, I had to actually train 5 different models, right? One model for email classification, another model for email the document classification, one more model for email entity extraction, another model for the document entity extraction, etc. These LLMs, because they have been trained on so many different parameters and so much data, you don't have to have different LLMs for each of the use cases. One single, and this is in a way we are, I'll say, not exactly correct statement, but our models have now become more general in nature, and in a way we are progressing towards artificial general intelligence. Okay, one way to take a look at it. Okay, so now taking a look at some of the industrial use cases of generative AI. So on the marketing and sales side, you can do a lot of creating translations, etc., creating code, writing code. So we are currently at least 3 projects I am aware of where we are helping our clients move from. So I talked about that Foxbase and Fox Pro and all that, right? So we are helping migrate COBOL code to Java. We are helping migrate, SQL queries, Oracle SQL queries to PostgreSQL queries, etc., like that. So those are some of the typical code related capabilities which are there with these models. Then creating summaries. So these are another way. Creating documentation from code or from diagrams, etc. So these are some of the typical use cases of Gen AI. And then concept of multimodal Gen AI also, where the same Gen AI model is able to take care of different realities. So you can throw a text at it and ask it to generate a video. You can throw a video as an input and ask it to summarize it into text. You can give it an image and ask it to generate another image, or you can give it an image and ask it to generate a video from it. Okay, so all these kinds of multimodalities are available to you. Okay, so that's your multi-modal LLMs, which are also coming in. And then there is this concept of, challenges with LLMs also. Okay, so hallucination, very famous, example. And what I'm trying to show out here is, 3 examples where I myself face this, hallucination problem. In the first one, I was asking DALI, which is another, generative AI foundation model, which generates images for you. So I had actually asked it to generate an image which has all 4 modes of transport. So road, rail, air, and sea. I asked it to generate an image which has all 4 modes of transport in it. Okay. What it ended up doing was it brought in the water, but it missed out on generating a ship for me. Instead, it created 2 aeroplanes. Okay. So this is an image kind of a hallucination issue. Then in between, I'm showing one example where Amazon Titan is another generative AI model, and I asked it to generate an architecture diagram for a particular claim processing website. Okay, so it generated a picture which at the initial thought, it looked like, okay, this looks like an architecture diagram. But the moment I took, a few seconds look at it, could make out that it was not at all, making sense in any way. Okay, first of all, the text itself, it doesn't look like it is, any particular language. It seems to be just random drawing of, what appears to be words. Okay, and even the boxes, they are not really an architecture diagram kind of a box, right? So basically, it just said that, okay, here's an architecture diagram for a claim processing website, but obviously it was not correct. And then simple hallucinations when it comes to numbers, etc. So I asked it which is a larger number, 1.09 or 1.01. And then it said that, okay, 1.011 is actually, so first it said 09 is actually larger than 011. But then when I said that, okay, are you sure? I think this is large. It immediately said, okay, I made a mistake. Let me recheck. And yes, you are correct. 1.01 is larger than 1.09. Okay, so like that, there are a lot of these challenges with the models because they need not be giving the correct answer. On top of that, so basically you cannot just directly throw a question to these models in the enterprise use case scenario. Okay, so for example, if I were to ask ChatGPT, okay, which is the best Vodafone plan, okay, postpaid plan for me, how will it know, what is the best plan, right? So maybe it might reply back to me okay, this fellow seems to be located in India, from the cookies or something, if it can find that information, and then maybe give me a general idea about, plans. I want this LLM to actually figure out who is this customer, what is the current plan, what is the current usage, and then what are all the plan options that I have as, say, Vodafone, which I can actually propose to the client. And then based on the data about this particular client and about my Vodafone plans, I should be able to answer better. Okay. So how do I train this LLM to answer based on the data of my clients and based on my enterprise? Where the concept of various ways of improving your LLMs comes in. Okay, so the first method is where you do prompt engineering, where you design the prompts. So there are various. Again, we don't have time to go through each of these in details, but you have something known as few shot prompting, one shot prompting, zero shot prompting, etc. So you give certain examples. Then there is something known as chain of thought. So you provide a chain step-by-step process by which you can actually, ask the LLM to respond to you. Then you have the mechanism of RAG, or retrieval augmented generation, where you can actually have, your enterprise database available to, the LLM. So it can actually, refer to that database and give you the solutions. Okay. And then finally, you have the option of fine tuning the LLMs also. The left to right sequence is basically we are trying to show increasing complexity of fine tuning these models, and at the same time increased quality also. Okay, so prompt engineering is basically the least complex or the easiest way to try and customize the LLM for your use. But having said that, the prompt engineering might not get rid of all your hallucination and other issues. Okay. Retrieval augmented generation is it's something that might take you a month or two. I'm actually currently doing a project for one of our clients, and we were able to enable a POC for it within a matter of 1 week. But now that we are talking about putting it into production, it might still take us a month or 2 months to actually take that POC to production. Okay. So, but then in a matter of, say, a month or 2 months, with a team of 3 of us, we should be able to get this working for our client. At the same time, the quality is much better now than prompt engineering, because now the LLM is looking specifically at certain data and databases which we are asking it to focus on. So there is very little chance of any hallucination or incorrect answers going out. Okay, but at the same time, it's still a best case or a best guess kind of a scenario from the database. Okay, the most complex, customization of a LLM is by fine tuning, where you actually have to spend a significant amount of time as well as money, because these LLMs, because they are trained on so many different parameters, billions of parameters. Typically, this training does not happen using your normal CPUs. Okay, we have to use GPUs, or graphical processing units. All of you might have heard, how the shares of Nvidia company have zoomed up in the last 2-3 years, because that's one of the top GPU making companies in the world, and these LLMs require GPUs. So something like a ChatGPT or a Gemini, it requires sometimes as many as 5 to 10,000 GPUs working for almost 3 to 4 months to come up with the next version of your Gemini or a ChatGPT. So fine tuning, say, a Gemini model for your use case. Basically, what you do in fine tuning is you retrain the Gemini or ChatGPT model which is available out of the box. You train it based on your specific data, so that the model itself becomes knowledgeable of your data. But as you can imagine, so that requires a decent amount of GPUs and a decent amount of time. So time and money both are required to perform this. But once the model is fine tuned, now it will give you the best quality output in the shortest amount of time. Okay, so that way this is expensive, complex, but provides the best results. Okay, versus prompt engineering, which is cheapest, hardly much effort required, but it might still be prone to issues like hallucination. So with that, I will try and take a pause here on this. I've tried to cover traditional machine learning all the way till generative AI. One thing I forgot was I'll not go into the details of this, but yeah, we'll talk a little bit because we've been talking about the Google platform. So I've put together a couple of slides. Again, all of this information is available on the internet. So the various services which are provided by Google platform for this enabling AI. So right from the infrastructure, so you have CPU, GPU, TPU, etc., which are available for training. So infrastructure as a service to your platform as a service, where you have in training, all these functionalities. You have Google BigQuery ML, which is in itself a AI-enabled solution. And then you have various PaaS and SaaS kind of solutions. So Dialogflow for your chat, contact center AI, document AI, etc., which are available for you to use. And then specifically with respect to generative AI, you have Google Cloud Services. Vertex AI is their primary enterprise solution. And then you have prompting possibilities. You have the model garden, where you have a lot of these LLMs and foundational models which are available. And then you have Google Gen App Builder, which can help you generate generative AI solutions. I think the next slide, yeah, this is where I have also tried to talk a little bit about the similar options are available from Amazon and Azure. Okay, so which platform you choose and which one you actually end up using is entirely up to you. But this is an architecture of a RAG solution using Azure. So I've used Azure Blob Storage, Azure Functions, Azure AI Vision, Azure Web Chat, Azure OpenAI as the LLM, and then Azure Postgres database as the database. So just like you have these services from Google, you have similar or equivalent services which are available on Azure as well as AWS. To be honest, Mithun, even I'm not an expert on AGI and ASI, but AGI is essentially artificial general intelligence, where it's like mimicking human. Okay, so just like you and me, when we step out in this world, we don't know. Like, suppose this meeting is done, and you step out from your home, or you step out from your college, or company, etc., or you just meet your friends, etc. You have no idea, right? What is the next challenge or next question that life is going to throw at you? So similarly, AGI, when we are talking about AGI, we are trying to mimic that human scenario where you can throw any and every question at these models, and they should be able to answer. So whether they have been trained or not trained, whatever they've been trained on, can they try and generalize that learning so that you can actually start answering. So that's in short about AGI. And ASI is where you actually go beyond human capabilities, and as we said, machine consciousness and all comes into the picture. So can you actually have a conscience and then try and answer your questions also? Okay, so that's in general, but it's something that I'll also take it as a homework to try and learn more about these. Okay, I hope I could somehow answer your question, Mithun. Uh, Ganesh, is RL like a trial and error, or please explain it again? Okay, so reinforcement learning, again, see, as I was saying, each topic can take hours or days, but reinforcement learning, yes, in a way, I think you've captured it well by saying trial and error, but trial and error with a goal. Okay, so in mind, goal you have to achieve, and then you have the environment, and then you take an action, and then based on the action the environment will react. Maybe a good example can be, if you can take a look at, I think there's the what was that snow sliding game. Okay, it's available on the internet, so you can actually start coding it and see how it works. So basically, it's like suppose you are on no surface, and you have to slide from one end to the other end, but you don't know exactly, in your path, where it is very slippery. Okay, so when you are actually telling the computer to take a right turn, it is trying to take a right turn because the snow has made it slippery, it ends up taking a left or some other turn. Okay, so it's basically uncertainties along the path which you don't know in the environment, and you just so the machine, you're not trying to tell the machine that okay, you have to take this action. You tell it that you have to go, reach this particular target, and based on that, it will try and take the best action. Every time it takes an action, it is going to try and get a feedback on that action. Was it a rewarding action or was it a punishing action? Okay, and then basically it will try and respond to it. Is human interaction required for results of models in Revolution 5.0? Okay, so that's a good question, Vishal. So far, what we are seeing is human intervention is required. Okay, especially when it comes to generative AI. Okay, the apart from the human intervention, so one way in which we are seeing a typical use case in the industry for generative AI is they are still last year 2023 it was all POCs. 2024 we have started actually putting generative AI applications into production, but still bulk of the applications which are going live, they are not really focused at the end customer. Okay, so for example, I'm working right now on a client for a US based healthcare insurance provider, and they are enabling a Gen AI based RAG based chatbot, but they are not enabling it for answering end user questions. They are enabling it for their customer service agents. So whenever a customer is having, say, a chat or a telephonic conversation with their agents, and he or she asks a question, the agent, that audio, we can convert that question from audio into text, and it will go and hit our Gen AI based chatbot, and the chatbot will come up with an answer, and the agent can read that answer that the bot has generated, and then respond on his own to the end customer. Okay, so that is how human interaction or intervention is still being put in between the customers and the latest Gen AI models. I think it's a matter of say 6 months, 1 year more. As businesses get more confidence out of this technology, I'm sure human interaction will slowly start going down. Good question, Raj. So again, bias handling, is probably one of the concerns why we still have this human interventions still coming into the picture. Okay. Now, the way you can get rid of bias, manually is very difficult because finally it's humans. If we are labeling the data, we are providing the data to the models. It's quite possible that we might be biased. So I don't know if there is, a perfect solution which has been found so far to get rid of bias. But at the same time, maybe more and more automation that comes in, where the machine itself is trying to identify what it needs to be trained on. That can be one possible solution. But at the same time, you'll have to put in some checks and balances to make sure that whatever it has selected also is not biased. Okay. So I don't know if there's a perfect solution to it, but yes, industry is taking a look at this. So various efforts are underway to take a look at how to solve this problem. Okay. Raj is asking, generative AI models often have to balance creativity with plausibility when generating content. How do they manage this trade-off, and what methods or metrics do we use? Okay, so there was actually, when you're talking about methods and metrics, I had a few slides which I didn't go into. So there is something, so I was talking about this RAG evaluation, right? Where we are in our RAG solutions, what we are trying to do is we are having the enterprise database, and when a user asks a question, instead of sending it directly to the OpenAI model, I will first try and find out the most possible best guess database documents which are related to this query, and then that database, entries which I picked up. So suppose I have 5,000 documents and the user has asked a question. I'll try and find out, okay, the top two matching documents and give that document along with the user question to the LLM. And then the LLM will decide, what is the answer. Okay. So now in this particular scenario, there are multiple ways to measure, the accuracy or, the functioning of the entire solution, right? First is this selection of the top two, best matching documents for this question. So I have to evaluate that. Then the second thing is having given the context to the LLM, how correct was the answer, that the LLM provided. Okay, so that is where things like RAG evaluation, RAGAs, deep eval. There are quite a few frameworks which are there, which are coming in, which measure all these metrics. So context precision, answer relevancy, faithfulness, context recall, etc. So these are some of the matrices which are used for measuring these generative AI solutions also.